In this lesson, I'm going to discuss how closed tubes resonate. As you go through this lesson, I'd like you to compare and contrast what you've learned in the lesson regarding open tubes as well as the lessons regarding resonance of strings. Right here I have 4 diagrams depicting the first 4 harmonics of closed tube resonance. I want to bring your attention to the fact that at the closed end of each tube we have a node. The reason for the node is that as the air molecules vibrate back and forth, they push another. And consequently, what happens at the closed end, you have air molecules that are pushed against that closed end and cannot go any further. So these air molecules here kind of get trapped and they end up forming a node. As you move away from that node, the air particles can move more and more distance, and the spot where we have the maximum movement we call the antinode. So as a result, the fundamental consists of 1/4 of a wave. We have one node and one antinode. Now when we go to the second harmonic, we double the first harmonic, so that means we have 2/4 that make up the wave pattern for the second harmonic in closed tube resonance. We have a node at the closed end, and we also have a node at the open end. And because we have a node at the open end, we don't have the air moving back and forth at the open end where we would expect the sound to come out. Consequently, we don't hear the second harmonic. Only odd harmonics are audible. If we go to the third harmonic is 3 times the fundamental. So we have 1, 2, 3/4, and we have our node at the closed end, and we have an antinode at the open end. Consequently, we do hear this one, because the air molecules can vibrate back and forth maximum where the antinode occurs. In the fourth harmonic, again, we have a node at the opening of the tube. Therefore, those air molecules can't vibrate right at the opening, so we don't have any vibrations of sound leaving that tube, so we don't hear sound coming out of the fourth harmonic. Again, only odd harmonics are audible. Now, if you compare the closed tubes to the open tube, and remember in the open tube the wave pattern consisted of half a wave, and in the closed tube the fundamental consists of a 1/4 of a wave. So if you look at the formula for calculating the frequency of any of these harmonic, their formulas are related, but instead of having a 2 here we have a 4. We have a 2 in the open-ended tubes because we have half a wave, and we have a 4 in the closed tube formula because we only have a 1/4 wave in the fundamental. So here's the formula for the closed tubes, and just as a reminder, the fundamental frequency is made up of 1/4 lambda.